Hello, good morning. This is Abhijit Mukherjee. Today we are going to study class 7 science. We have been doing the chapter 15 light. In the chapter we have already learned in the previous class about concept of light and reflecting surfaces, regular and irregular reflection, which is also called diffuse reflection. We have learned about the different types of surfaces, that is plane surface, and the characteristics of the images in a plane surface. Today what we are going to study is about spherical surfaces, diverging surfaces and converging surfaces, about mirrors, concave mirror and convex mirror. We are also going to find out the usefulness and daily applications of these mirrors, as well as we will find out the use of lens and their properties of image formation. As the name suggests, a spherical mirror is a part of a sphere. If we take a hollow sphere and make a straight cut through it, we get a portion of the hollow and a concave inside and a bulging and convex outside, as in figure 15.5. So on the left hand side, what you see is a convex mirror which is bulging outside, and the reflecting surface is on the left hand side. The right hand side is the non-reflecting side. In the right hand part of the spherical portion, you see the concave mirror. Here also the reflecting side is on the left hand side and the non-reflecting side is on the right hand side. So when you draw a convex mirror or a diverging mirror, we will draw this type of mirror. The rays of light after incident on this surface of the reflecting convex mirror will diverge out. In this case of a converging mirror or a concave mirror, the rays of light after incident on the surface will converge towards the center. So a convex mirror will diverge the rays of light after incident on its surface, while a converging mirror or a concave mirror will converge the rays of light after reflecting on the surface. So a convex mirror or a diverging mirror is a spherical mirror in which the reflecting surface is the outer surface of the bulge. Let us find out in an activity with the aim to study the different types of images formed by a convex mirror. You need a highly polished convex mirror surface like a spoon or a ladle, a candle with a holder, a tabletop, a thick piece of cardboard covered with white paper as a screen, and a plane mirror. The method would be at first to place a lit candle on the tabletop between the screen and the convex surface. Next, we should place the convex surface close to the candle and move the screen back and forth to get an image of the candle flame on the screen. We will now repeat this process for various distances between the candle and the convex surface and find out our observations. Let us look into the convex surface from behind the candle. What will we see? Based on these observations, let us fill out the following table. Is the image upright or inverted? Upright image. Can you touch the image? No, we cannot touch the image. Is the image real or virtual? The image is virtual. Is the size of the image bigger or smaller than the object? The image is diminished than the object. Is there any connection between the inverted upright nature and the real virtual nature of the image? Virtual image is always upright and real image is always inverted. When you move the object closer to the mirror, what happens to the image? The virtual image diminishes in size and comes closer to the mirror. What happens to the image when you move the object farther away from the mirror? The virtual image increases in size and it goes farther away from the mirror. What happens to the image if the object is very close to the mirror? The virtual image diminishes to a point image. No matter where you place the candle, you will not get an image of the candle flame on the screen. However, when you look into the convex surface from behind the candle, you will see an upright and diminishing image of the candle. Diminishing image means the image that is smaller than the object. In this activity, we may also observe that as we move the convex surface farther away from the candle, the image of the candle will become smaller and more objects around the candle will come into view. This shows us a convex surface as a wide field of view. So this finds usefulness in our daily lives, like for viewing the entire vehicle background as well as the surroundings. Convex mirrors are used as rear view mirrors or wing mirrors in buses and other vehicles. They are also used in supermarkets and parking lots. The property of a concave mirror, by which it forms an enlarged image when the object is very close to the mirror, is used in dentist mirrors to make it easier for the dentist to examine your teeth, and ENT doctors for checking your eyes. Saving mirrors, for example in 15.6 figure, is also based on the same property of concave mirrors. Spherical lenses. A lens is a carved and polished piece of glass or any other transparent material. Just like mirrors, lenses can also change the direction of propagation of light. There are convex lenses and concave lenses, which are the two common types of lenses. Convex lenses are called converging lenses as they bulge in the middle and they are thinner at the two ends. And it is used, for example, in a magnifying glass and in spectacles for reading glasses. Let's see an activity with the aim to study the images formed by a convex lens. The materials required will be convex lens like a magnifying glass, a screen, a candle, tabletop, and measuring tape or ruler. Let us go outdoors and hold the convex lens facing the sun, keeping the screen behind the lens. Let us move the lens back and forth that we get a sharp image of the sun on the screen. And this is the focal point represented by F. Let us place the lens between the screen and the candle. Start the lens very close to the candle and move the screen back and forth till you get a sharp image on the screen. If the lens is very close to the candle, we may not get an image on the screen. In case we look through the lens, we will see an enlarged view of the candle. Let us repeat the activity by slowly increasing the distance between the candle and the lens and move the screen back and forth each time to get a sharp image. And make a note of these observations. If the lens is very close to the candle, an image is formed on the screen. Such an image is called a virtual image. If the lens is at a distance from the candle, the image is formed on the screen. That is called a real image. Conclusion: a convex lens can form both real images as well as virtual images. The virtual images will be enlarged and upright, and when the object or the candle is very close to the lens. Uses of lenses. Both convex and concave lenses are used in spectacles to correct eyesight. Convex lenses are used as reading glasses, while concave lenses are used to correct short-sightedness. Lenses are used in cameras, magnifying glasses, binoculars, microscopes, and telescopes. Picture is given in figure 15.8 A and B. Our eyes also have lenses inside them. Let's solve page 236. Let's remember part. Writing true and false. Number 1. Spherical mirrors form exactly the same type of images as plane mirrors. This is false. You have to write in different types of images. Number 2. A concave mirror can form both real and virtual images. This is true. Number 3. A concave lens can be used as a saving mirror. This is false. Answer should be concave mirror. Number 4. A convex mirror is used as a magnifying glass. This is false. The answer should be convex lens. Number 5. A convex lens is also known as a diverging lens. This is false. It is a converging lens. White light is composed of 7 colors: violet, indigo, blue, green, yellow, orange, and red. These 7 band of colors is called spectrum. It is visible to the human eye, so it is called visible spectrum. Now, when the light passes through a glass prism, this splits up in white light into its constituent colors. As in figure 15.9, it is called dispersion of light. Another method can be used to show the white light is composed of different colors is when we use a Newton's color disk. Is painted with constituent colors of white light, all weaves here in equal proportions, and when rotated very fast, the disk appears white. Image formed by the eye remains for a fraction of a second, and at a high speed, the images of different colors overlap in our eyes, and the brain perceives as it white. Let's solve page 237. Let's remember correct words. Number 1. White dash prism light can be split into its constituent colors. The answer is white light. Number 2. When white light is split, splits into a band of colors called the dash, visible or invisible spectrum. The answer is visible spectrum. Number 3, a colored disc painted with the constituent colors of white light in equal proportion appears dash, white or black when rotated. Answer is appears white. Page 240, long answer type question. Question 4 number part 2. You are given a plane mirror, convex mirror, convex lens, concave lens. Give 2 methods by which you can form diminished images of an object and 2 methods by which you can form enlarged images. A convex mirror will always give diminished images and upright images. A concave mirror will give diminished images when the object is placed quite far away from the focal point. But as we bring the object closer to the focal point and closer to the mirror, we will observe enlarged images. Concave mirror also gives enlarged images when object is very close to the focal point. That's all to the end of the chapter 15, Light. Bye. Take care.